Right. So we just finished part A. Part B says make a sketch of the distribution. It is already known that there will probably be one peak because there's no obvious reason why the exam scores would form different groups. Recall that a single peak distribution is symmetric if its left half is a mirror image of its right half, left skew if its values are more spread out on the left side of the mode, and right skewed if the values on the mode are spread out on the right side of the mode. I know it doesn't make very much sense, but this distribution is probably skewed to the left because we have a lot of A's. So that's our higher value. Typically, you would have the values go from low to high, and our higher values are our A's. We have 34 A's versus 10 B's and 21, or sorry, 34 A's, 10 C's, and only in 21 B's. If our 34 was the B's, you probably have a more central distribution, okay? But you would typically go from lower score to higher score, and that would make it skew what they call a left-hand skew. So the values are over here on the right-hand side. So a left-hand skew actually shows your hump over at the right-hand side. Okay, so it's just kind of the opposite of what you would think a left-hand skew would be. Left-hand, I would think it'd be on the left-hand side, but it's not. It's on the right-hand side. And that's because our right-hand values are over here. And your left-hand stuff, there's very little, like your F's and D's. We didn't have any of those. So that's kind of what's going on there. What shape would you expect from the distribution? So you would be asked to graph it, and you would pick the graph. From this graph, I need you to know that because this is on the right-hand side, it's actually a left-hand side, a left skew. If the hump looked like that, that is a right skew, right skewed type problem, okay? So part C, what shape would you expect from the distribution? The distribution tends to be symmetric when it's equally likely for the measure values to be larger or smaller than the mean value, okay? If there are any obvious upper and lower limits to be measured to the measured value that is close to the mean value, then the distribution tends to be skewed away from the limit. Okay, so we didn't really have any F's or D, and that's why we've got this skew going on. Because again, and also so many more students got A's than C's, okay? So if it would have been symmetric, if C's had been more prevalent, we would have had a skew like this, like a right-hand skew. But because we had more A's than we did C's, we got this. If we had equal number of A's and C's, we would have had a distribution that looked like that, which is even. Okay, so if our A's and C's were very similar, you would have had a distribution more like that. Okay, and with this particular problem, what variation would you expect in the distribution? The distribution has small variation when all the values are very near the same. It has large variation when the range of values is large fraction of the average value. Otherwise, it has a moderate variation. Here, we would have a large variation because so many students got A's. Some got B's, and a very small number got C's. And so the data are not clustered. So there will be other problems like rainfall and such, and the price in dog food, and they don't tell you necessarily how much everything is. And so some of that you will have to assume it's going to be a moderate because there's no reason why there should be huge variations within dog food, and so on and so forth. Unless they tell you that there's a huge variation between things, you should not assume that there would be. Email me with any questions, ask me in class.